and share the slides. So guys, can you see the slides now?
Yes.
Yeah.
Awesome. Thank you. Uh,
Yes.
so guys, today we are going to discuss quality management. I really love this knowledge area because like it's pretty interesting. Uh, there are many different tools and techniques that mostly I use in my engineering projects. So I really liked it. But before going and discussing quality management in depth, uh, let's have a bit of discussion around our yesterday's topic that was uh, cost management. So Tanya, uh, what do you think? What you learned yesterday about cost management?
Yeah, it was good just going through a lot of the tools. I need to still get my head around the equations and things, but that's really just practice and becoming familiar with where where parts are on the line.
Yep.
But really thorough, I thought.
Yep.
And yeah, I found it good.
Yeah, so Grace, yesterday we were talking about cost management and we discussed in total 4 different processes, starting
Yeah.
with that standard process of planning for the cost. And this process is called plan cost management and its output, as you can expect, is cost management plan. That is a subsidiary plan about the cost. And that plan is about our thinking how we are going to estimate the costs for different activities, for different work packages, for the whole project, so on and so forth, and how to manage the cost during execution, and how to monitor and control the cost so that our expenditure should be aligned with our cost baseline. And we also look in depth in estimation or cost estimation, and we had a look on many different estimation techniques, but you have already mm, already acquainted with those techniques while we were discussing schedule management, mean analogous estimate or heuristic estimates or top down approach or bottom up approach, single point estimate, 3 point estimates, and weighted 3 point estimates, so on and so forth. We also learn how to aggregate different cost estimates and how to determine the contingency reserve to determine our cost baseline. And baseline is something against which we measure our performance, our expenditure performance. Uh, we also determined the budget for our project. We talked about different funding options. We have seen that normally how excuse me, how budget is reconciled over the period of time, uh, how budget is available for us over the period of time, how can we set our schedule according to the availability of the budget. At the end, we talked about control costs. In fact, we didn't. We not only discussed control cost. We talked about control schedule, control scope, in an integrated fashion. If you remember, guys, we talked about our different baselines, and that were scope, schedule, and cost baselines. And then we said that uh, in total, they are called performance measurement baseline. So performance measurement baseline (PMB) is an integrated version of cost, schedule, and scope baseline. Then we have seen the one of the most common technique for monitoring and controlling our project work, monitoring and controlling our schedule, scope, and cost. And that technique was earned value management. I'm not going in depth of earned value management because it is a thorough topic, but once Grace, you will get the video, then you will come to know more about earned value management or earned value analysis, how we do it, what is S curve, and how we can use the S curve to see that how we are performing, how much is the variance, uh, how is our performance going, called performance index in terms of cost, in terms of schedule, how much more budget is needed, what would be the overall cost of the project. All those bits we have seen in our yesterday's session. Uh, Now we are going to discuss our fifth knowledge area. Uh, I reckon that is quality management. When we talk about quality management, excuse me, uh, basically we are talking about, firstly, we are going to define quality management, or in fact, defining the quality. And the definition of quality as per PMI is very simple, very short, but we need to remember it for our exam purposes. And this is given here. Degree to which the project fulfills the requirements is called quality on any project. Now, these requirements could be about cost reduction, by reducing the rework, by reducing the scrap, or by meeting the customer requirements, or satisfying the customers. All these are different type of requirements we think in terms of quality. So quality is nothing but a degree to which the project fulfills the requirement. Everybody should remember this particular definition for the exam purposes. Here on the same point, I am going to define grade. But before defining grade, can anybody tell me what's the difference between quality and grade? Anyone?
Is it to do with the complexity of a product, or or quality requirements that are needed to pass it? I'm not sure.
Yeah. Yeah. So let's see the difference, degree and quality and grade. Uh, First thing is, quality could be low, could be high, of any project deliverables, any product. Similarly, if we talk about grade, grade could be low or high too, uh, of any product or its functions or any project deliverables. It is important to understand that quality and grade both are different things. Grade could be low, could be high. It's all right. But when we talk about quality, quality must not low. It should, our project deliverable should be of high quality. Yeah, based on the client requirements, based on the budget, and the deliverables, the project deliverables, or the product that we are producing could be of low grade. We can build a 3-bedroom house by spending, you can say, a 3-bedroom house that is 100 square meter with the help of 200K. Okay, the same 3-bedroom house, 100 square meter, could be built with the help of 250K. Okay, what would be the difference? The difference would be the grade of the house. Functionality is still same. It's 3-bedroom. It is 100 square meter, but the material that is used could be comparatively of low or medium grade. But in any case, the quality of both houses should be appropriate. Things should be of high quality. The deliverables that we produce, the product functions that we produce should be of high quality. For example, let's take the example of two mobile phones. One mobile phone is, for example, those with a keypad, the old style keypad Nokia phones. Okay. Yeah. Now, this is a low grade phone. On the other side, we have a touch screen phone that uh, that has like a lot of functions, a lot of features, but the most important feature is the call. Okay, if our low grade phone, it works fine and you really don't get any noise while you are talking with anybody else, I mean it is fulfilling the requirement, it is of high quality, it is doing the function for which it was built. On the other side, mm, uh, this phone is very fancy, a touch screen phone, and we are saying that there is a lot of RAM and there is SD card availability, LCD is fantastic, camera is very good, but the thing is like, for example, its calling quality is low. No doubt it is a high grade phone, but its quality is low. That is not acceptable. So this is the difference between quality and the grade. Grade, in formal definition, refers to a general category of deliverable that indicates common functions but varying technical specifications. That could be low spec, that could be high spec, but important thing is low grade product is acceptable. It totally depends on the budget of a project or client requirements, but uh, quality should not be compromised. Now let's go back to our first slide, mm, where we are going to talk about quality management process. When we talk about quality management, basically we are talking about three main processes. The first one is how we are going to plan for the quality on our project. Second is how we are going to manage quality while we are executing the work, while we are creating the work packages, creating the deliverables. And then there comes our last process, that is control quality. And it is about once a deliverable is completed, once a work package is completed, now we need to verify, we need to inspect, we need to test that deliverable to confirm that, okay, before going in the hands of the customer, it should be of high quality. In other words, it is a three-stage process. The first stage is where we do the planning for the quality. What standards we are going to use, what quality metrics we are going to use, what what are the quality requirements from the client, from the organization, who will be responsible for the quality activities, who will ensure the who will assure the quality, who will control the quality, what how many activities are required to assure and control the qualities. Everything is everything is thought here in our plain quality management process. That is our first process in quality, and it is part of our planning process group. And after that, as our work starts, what we do, we keep on managing the quality. We keep on assuring the quality. In fact, in the previous version of PMBOK, that project management body of knowledge, that main book, that main guide published by PMI, the process name was not manage quality but assure quality. However, in version 6 that we are currently using, they changed the name from assure quality to manage quality. In fact, manage quality you can think of is a superset or more broader term than assure quality. Assure quality is talking about that, okay, quality must be built in while we are working. But managed quality talks more than that. It says that not only our quality should be built in our work, but When we do quality control activities, the feedback we receive from quality control activities, we should also incorporate in our upcoming work too. So, manage quality not only includes assure quality activities, but the feedback coming from control quality activities. Now, it is highly recommended when you are going to talk about quality, always spend more time on prevention rather than dealing with the issues, rather than doing the rework, rather than uh, repairing the defect, repairing the bugs, or taking care of the scrap. So quality assurance is more important than quality control. Or in a broader term, quality management is more important than quality control. And from here, you can also can understand where quality management is talking about. Okay, quality should be built in our deliverables. Quality control is the process that is executed when our deliverables are produced. Okay, so it is not something that is during execution. It is not something that is building. This is the work that we do at the end. For example, uh, developers in software industry, they wrote the code, testers come, they test it with the help of many different techniques. Similarly, QA/QC guys on all different type of projects, either they are telco projects or construction projects or any other industry, quality control is always done with the help of many different techniques. For example, walkthrough, inspection, uh, and evaluation, checklists, so many different techniques. In fact, we are going to study few of the techniques today too. Any questions so far?
Oh,
Okay, so we can move further and we are going to define our quality management. We already defined quality, we already defined grade. Now we are going to define quality management. Quality management is basically done most of the times on the organization level. Each organization has its own quality management system to, to ensure the quality of the organization. It talks about many different aspects. It talks about governance. It talks about for example, support function. It talks about engineering function, development function, for too many different bits, the quality management system. In fact, the quality management system for different industries and different organizations, they are different because their work is different. But one thing is common in quality management systems or in quality management, basically we are talking about the policies and the procedures and how to tailor and use them so that the projects that organization is doing or the operations the organization is doing on day-to-day basis meet the needs of the customers or the stakeholders. Before going in depth of different processes, let's talk about some concepts that are pretty important for the exam point of view. Okay, and we can say that these are the concepts related to PMI is. PMI is means something how PMI looks on different concepts, different things. What are the beliefs of PMI in related to the projects? Let's go through one by one and see uh, what does it mean. Now, Pedro, can you go through first point?
Quality means meeting requirements, not adding extras.
This is very important point. We really don't want any gold plating. Okay, gold plating on the projects are not allowed. If you completed the project under budget within the schedule, it's all right. Return the resources, return the budget, return the leftover money to your project sponsor. You shouldn't keep on adding more and more functions and uh, feature into the product, into the service, only for the sake because time is left, or we still have money in our budget. We shouldn't waste that money and should be returned to our project sponsor. Our task is to meet the requirements. We must not exceed those requirements. Next.
Project manager must determine the metrics to be used to measure quality before the project work begins.
So normally what happens is quality policy, quality management related policies, procedures and templates are always available at the organizational level with the project management offices, but uh, it's a responsibility of project manager that to tailor those processes and procedures as per the need of his or her project. His responsibility also include to determine the right matrices that could be used to measure the quality on the project. Those matrices are very much specific with the type of the project, with the nature of a project, with the type of the industry, so on and so forth. But few examples could be the number of bugs produced, and the number of defects in the deliverables. It is just one measure of quality, and how quickly those defects are removed, and other metrics and other measurement. And in fact, for manufacturing industry, for example, these medicines are totally different. They talk about Six Sigma approach. They talk about some control charts where they look on that how effective are like their processes, their machineries who are producing the products, so on, so forth. So it's important that project manager should determine the appropriate metrics for his or her project. Next, Pedro.
Project manager must define quality management processes.
So if organization has already some requirements for the projects related to quality, some processes to adhere, it's good. Okay. Sometimes if those processes are not available, project manager also have to define those processes. And if processes already exist, still he or she can tailor them for the need of the project. Next.
Project manager should recommend improvements to the performing organization standards, policies, and processes.
So in case if project manager is following organization's standard policies and processes, if he or she got some learning, some feedback that okay, this is a process or this is a procedure, this is a form related to quality, it needs to be improved or it can be improved, then he or she can give this feedback, this recommendation back to the organization so that organization can improve those processes, policies, and procedures at the organization level for the other project teams. Next.
Quality should be checked before an activity or work package is completed.
So basically here it is talking about quality control, QC. QC talks about that before demonstrating the deliverables, before handing over the deliverables or the work packages to the customer, it's very important that uh, quality control work should be done on those deliverables. Once quality control work is done on those deliverables, normally we call them verified deliverables. So for example, always understand what does it mean verified deliverables. Okay. And once deliverables are verified, we can go and show to the customer for the sake of acceptance. And if those deliverables are accepted, then we call them accepted deliverables. So there is a difference between verified deliverables and accepted deliverables. Grace, can you please help me to read this slide one by one?
Sure. Project manager must ensure that authorized approaches and processes are followed.
So it's very important that project manager have a good understanding that what are the quality management related approaches and processes that will be useful, that are authorized for the project. He or she should adopt only those authorized approaches and processes. These could be industry standards, that could be regulatory requirements, that could be organizational level requirements, so on and so forth. And when we talk about authorized approaches and processes, they should be adopted for the product, for the project, and for even project management work, for all three bits: products, project related work, and project management related work. Next.
Quality should be considered whenever there is a change to any of the project constraints.
Yeah, so it is same concept of integrated change control. Whenever there will be change in project scope or in the budget or schedule or resource has left or a new resource is added, always think about quality and how it will impact on the quality. Will it improve the quality or reduce the quality, or we need to do some extra activities to ensure the quality on the project, so on, so forth. Next.
Project manager must ensure that the quality, standard, and processes on the project are adequate to meet quality requirements.
So yeah, so that's important that only those quality standards and processes should be used, as we already discussed, that are required for our project quality, our product quality, and project management related work quality. Only those standards and processes should be used, because it's very important to understand that we really cannot spend extra on the quality, especially if it is not required. Yes.
Some quality activities may be performed by a quality department.
Basically, it is talking about that ultimate responsibility of quality management is with the project manager. However, some activities related to quality assurance and quality control is done by the project team members, especially those team members such as testers or the people coming from the quality assurance departments, so on and so forth. But there could be some activities that are done directly by the quality department. For example, audit or quality audit, that is normally done by the QA/QC department. Any questions? Okay, let's move further. Sukanya, can you please help me to read this slide?
Sure. Gold plating. Giving the customers extras means extras functionality, higher quality components, extra scope, or better performance.
Yeah, so this is gold plating, but we really don't want gold plating on our project. No extra functionality, no higher quality components, no extra scope, no better performance than required. In fact, advanced quality thinking, advanced quality techniques really doesn't recommend exceeding as a best practice. Meeting is the best practice as compared to exceeding the expectations. Uh, Last point.
All available effort should go into achieving project objectives instead of gold plating.
So once our project objectives are achieved, in fact, we are salted. We really don't need to do anything extra. Yeah. But, sorry, yeah, Eman, can you please read this slide for me?
Preventive over inspection. Quality must be planned in, not inspected in.
So this is basically talking about quality must be built in while we are doing the work. We should take those measures, we should do those activities, we should add those skills into our team so that they can assure the quality, should build the quality while they are doing the work instead of checking the work at the end. Next.
Continuous improvement, Kaizen. Continuously looking for ways to improve the quality of work process and results.
In fact, Kaizen is very famous term, is used in many different industries. And the purpose of Kaizen, a Japanese word, in fact, there are two words, Kai and Zan. Kai talks about continuous and Zan is talking about improvement. It is about improvements that could be in small increments, but they should be continuous so that the quality of work, either it is on a project or even on daily operations, the processes and the results, they should keep on improving over the period of time. Small increments, but continuous increment. That is basically Kaizen approach. Few more concepts, Tanya.
So just in time,
Yeah.
Companies have suppliers deliver resources just before they are needed, thus decreasing inventory to nearly zero.
Yeah, so that's we already discussed when we were talking about start to finish. Start to finish or just in time are exactly the same concepts. They are talking about that suppliers deliver the resources just before they need it. Okay. By doing that, inventory become almost zero because inventory management, inventory storage, inventory control, it is a big task. It requires a lot of resources. So now everybody is preferring that instead of keeping big warehouses in the backyards, it's better that the suppliers should deliver only when it is required. Okay, but when we are doing JIT, we also need to think about quality and we also need to think about schedule. Next.
Responsibility for quality.
Yeah.
Project manager has the ultimate responsibility for the quality of the product.
Yeah.
Or the, what?
Yeah. So can you please keep on reading?
Yeah. Each team member must check their work by inspecting it themselves.
Ultimate responsibility is with the project manager. Reason? It is his or her project. The success of the project is success of a project manager. But normally there are some roles and responsibilities related to quality. In fact, each team member should assure the quality for his or her own work. In fact, there are many different techniques through which we can build the quality in. We can assure the quality. One of the technique, for example, is called pair work. Pair work is a fantastic technique that is again started initially in the software industry, but now many industries are using the pair work instead of one person is doing the work and after that someone else is checking. In fact, two persons physically sit together and work on one work package, work on one activity. One is doing, other is assuring quality. I also have personal experience working as a peer worker, and it really improves the quality because two persons are focusing at a time. One is developing, other is assuring the quality, and the results are much better instead of checking the quality at the end. We already understood this difference, isn't it, guys? The difference between Plan quality management, manage quality, control quality. Can anybody tell me the difference between three? The first process, basically these are three processes. First process is our quality management plan. It is talking about what processes will be used, what procedures will be used, uh, what quality metrics will be used, what quality reports will be generated, who who are responsible for quality related activities, so on, so forth. Everything is decided in our quality management plan that later becomes the part of our project management plan. And manage quality is nothing but assure quality, or in fact, bigger than the assure quality. This work is done while we are executing our project. When we are creating our work packages, we really want that whatever we planned here, okay, should follow here. Okay, our work should be done by following our quality management plan, its policies, the standards, the procedures, the processes, so on, so forth. By doing that, uh, we can prevent what? We can prevent the defects, we can prevent the bugs, we can prevent the scrap, we can prevent the return of the item or rejection of the item from our clients. The control quality, this is inspection once our deliverables are produced. Okay, this is not building. Control quality is not building, but inspection at the end. Always remember, control quality talks about on the completed deliverables, not those deliverables who are under progress. Now let's go in depth and talk about plan quality management. In fact, we did it. We talked about it. We already discussed that while we are planning for the quality, we identify all the suitable organizational or industry standards and practices suitable to what? Suitable for our product, suitable for our project, suitable for our project management efforts to ensure the quality of all of them. And also, not only those standards, processes, and procedures, but how to tailor them, how to define them as per the need of our project, so that we shouldn't put more quality effort than required. It should be appropriate to our project need, because we always have to balance our project quality uh, with our other project constraints. We really don't want to spend 6 out of 8 hours on the quality assurance. It will do nothing but delay our project. When we are planning for our quality management, we can use many different tools and techniques. We can conduct interviews with subject matter experts. We can sit together, can do the brainstorming related to uh, what processes needs to be used, what quality medicines need to be established, what roles and responsibilities will be there, and also we can use the technique of benchmarking. Do you guys use benchmarking?
In some instances,
Yes,
such as machine capability or
yeah,
capacity.
true. So when you do benchmarking, what do you do, Tanya?
If it's for, we did an exercise on the PMPs,
Yeah.
the theoretical maximum productivity of a piece of equipment. So we gathered information from the manufacturers. We went back over our own data
Yes.
as well for performance, and we compared that with another organization that had similar equipment.
Yeah, fully agreed. So what we do, we normally try to benchmark our KPIs, our objectives with the best in the industry, or maybe with the manufacturer specifications, maybe with some databases, uh, or some national level benchmarks, so on, so forth. Another technique that is used during planning is called decision making. It is very important while we are making decisions about the quality, because quality comes with the cost. But we have to determine that optimum point where our quality should be balanced with other project constraints such as schedule and cost. And normally decision making is done when we are choosing between more than one options. Similarly, we can conduct cost benefit analysis, and this cost benefit analysis will be talking about cost versus quality. Okay, how much ROI we will get if we will spend a particular amount of dollars on the quality, on quality conformance, on inspection, on evaluation, or on the testing. Any questions here?
All good.
Thank you, guys. Now let's move further and talk about another tool and technique that is basically, excuse me, that is basically cost of quality. In yesterday's session, I talked about cost of quality. It could be of two types: cost of quality conformance and cost of quality non-conformance. And everybody would be agreed that we would like to spend on cost of quality conformance instead of spending money on non-conformance. Reason: because the cost of quality non-conformance could be much bigger, could be thousands of times bigger than cost of quality conformance. And this type of cost is like include not only the defects, the rework, the scrap, the claims in the warranty, but most importantly, your business reputation. All these costs are too much. If you remember, yesterday we talked about this graph where we said that cost of quality conformance is high in the start of a project, but it goes down with the passage of time. On the other side, cost of quality non-conformance is less uh, in the start, but it can increase exponentially. And we talked about that we should find a point, an optimum point where we can balance out this cost. I mean, we should spend appropriate time and money on ensuring the cost. Uh, Now let's take the example of cost of conformance. It includes training, research and studies, uh, the time, the resources spent on measuring the interim deliverables or quality assurance, some surveys that you can conduct from your customers. It takes time, energy, resources, and obviously the cost. And then how to ensure that, okay, training is done, research and studies are done, we have made the policies, we have developed the quality matrices to measure the quality of interim deliverable, but how to ensure that everyone on the project team knows that we have to do this to complete their work. In fact, quality management systems are developed everywhere. Quality processes are everywhere, but sometimes quality suffers. The reason is like employees or project team members, they really don't follow those processes. On the other side, cost of non-conformance, we already talked about it. We have seen the examples that include rework, scrap, inventory cost, warranty cost, loss of business, and loss of business reputation. Few more tools and techniques. I won't go in depth of them. The reason is like they are not important for exam purposes. And again, normally QA/QC guys use this type of techniques in more depth than the project managers. One of them is logical data models. These models talk about or they contain the quality needs of a project. Okay, and from those quality needs, we can develop the plan for our project. Similarly, matrix diagram talk about basically matrix diagram is nothing something like that. And that says okay, different project objectives or deliverables. Okay, and on this side you can say that quality requirements, and this matrix tells that which quality requirements are of high importance as compared to others. Similarly, we can use the mind mapping. Mind mapping talks about different quality requirements and their sub requirements in more depth. And also we can see that how much are they important as compared to other project related requirements, project related activities. So this ugly diagram is a mind map. Another technique, flowchart. Sometimes people also call process map. What it shows that how your process flow from start till end. What are different components, mm, different steps in a process, how decisions are made, how different workflows or different activities are handed off to the next team member, so on, so forth. Okay. So this type of flow chart can help us to identify the quality requirements on each step, quality requirement when there is a transition from one point to the other point, so on, so forth. It also not only help to identify quality requirements, but also quality problems on all different steps and interfaces. Another tool and technique that could be used while we are talking about quality management planning, it is related to quality control and talks about testing and inspection. Testing and inspection is always one of the most important part of any project. Normally where we have our doers, we always have our testers. In fact, you might heard about test driven development. That says that firstly we define the tests, then we try to meet those test definitions by doing our work. uh, meetings meetings is a technique, as you can understand, but this time the focus of these meetings could be around quality planning for the project. Outputs, as expected, quality management plan is one output. This will become the part of project management plan. The second output is quality matrices. These are well defined to the point matrices related to our projects, related to our project deliverables. And there could be some updates in the project management plan, in the schedule, in the cost estimate, and the project documents, especially risks or assumptions. Then there comes our second process, that is manage quality. Previously, it was assure quality. Before discussing manage quality, any question regarding first process? Did that process make some sense?
Yeah.
So now our quality management plan is developed. We have to follow that plan while we are managing our quality. In fact, one of the important task of manage quality is follow our quality management plan. Okay, we manage the quality when project work is being executed, and we also ensure that the project work we are doing is following the processes that were chosen, that were selected in our quality management plan, and the deliverables that are being produced, they are conform with the quality management plan. That is basically quality built in. Quality is being assured when work is being done. We also assure that quality standards are met. Not only met, sometimes we also can review those quality standards so that they should be effective, they should be fit for purpose for our project, and they are used correctly on our project. Number of tools and techniques are used in this process. We will not go in depth at this point of time about those tools and techniques. The reason is the tools and techniques that are used in manage quality, almost similar tools and techniques are used in the control quality or quality control. But let's have a look on these tools, and let's share each other's experience. Uh, do you use any of them or not? The first tool, Tanya,
Yeah, for sure, checklists.
your checklist. Do you use checklists?
Yep.
Yeah, so Grace, you use checklists. What's the purpose of checklists?
Just to capture the items that you might miss in the
Yes,
process,
true,
and the checklist will provide you sort of like a guidance
true.
of what you needed to do.
Yeah, so minimize the human error in case if they are doing a quality work, but because of some human error, they might not fully follow the process because of one reason or the other reason. So checklist assure that quality is there on the work. And normally checklists are like more checkbox exercises. There is a list, there is a guidance, and you keep on checking and uh, keep on checking the product and keep on ticking on the boxes. And then there comes another type of checklist. We normally call it check sheet. Check sheet is a derivation of checklist. Anybody use check sheet?
Yeah.
Yeah. So what do you do in check sheet, Tanya?
It wasn't so much on a project, so a pre-operation check sheet for operating equipment,
Yep.
for example.
Yeah. And what type of entries are there on the check sheet? Do you do some type of recording on the check sheet?
Yep, it's really just identifying if there's any variation to standard. So
Yeah,
if there are any issues with a particular piece of equipment,
true. So
let's go through.
yeah, and do you do something like this instead of just doing tick or cross? Do you also count how many issues are there or how many equipment are faulty, something like that?
I've worked with a variety. The tick definitely having more information is a better safeguard than the ticks and crosses because
True,
people tend to get a little bit lazy and just do all the ticks without actually doing the checks.
true. I fully agree. In fact, that's why this derivation is there to capture more information than the checklist, than just tick and crosses. Okay, here they sometimes we call them tally sheet. Not only you do check and crosses, but also count the things, count the errors, or count the correction needed, and totally depend on the nature of a project. We will look on check sheet or tally sheet soon. Next is cause and effect diagram. Anybody use it?
Yep, use Ishikawa.
Yeah, Ishikawa, the famous Ishikawa, the professor Ishikawa from Japan. He invented this technique, this quality assurance technique. Uh, it is also called fishbone diagram uh, because it looks like a fish. Uh, we are going to discuss fishbone diagram or Ishikawa diagram in more depth soon. Histograms. Histograms are nothing but our bar charts, isn't it?
Yeah.
But they really don't talk about the criticality, or they really don't talk about the frequency of the items. Uh, a derivation of histogram is, maybe it's given here, but it's not given here, is called Pareto diagram or Pareto chart. Uh, the difference, I'm going to explain it here. Histogram is nothing but our bar charts. For example, say that we are checking the doors on a five-star hotel that is just completed, and quality team is there, inspection team is there, who are checking the quality of the doors, and they determine, okay, 10 doors are taller than required, 2 doors are shorter than required, and 30 doors are very wide, they even can't fit, uh, and there are around 20 doors that are, like, you can say that they are not wide, but they are uh, more short. Okay, something like that. But you can see that more issues are with the doors which are wide than that are tall or short, or long or short. Okay. On the other side, when we talk about Pareto diagram, in Pareto diagram, we put our bar charts in such a way that we can see where are more critical, more frequent issues, which errors are more frequent. Advantage, there are many advantages, in fact. There is a rule called 80-20 rule. How many of you know about 80-20 rule?
Yeah.
So 80-20 rule could be applied to anything. Yes, Tanya, any example?
I was just going to say that 80% of your issues will typically come from 20% of your.
Fully agreed. So 80% of the issues come from 20% of the problems. If we can resolve 20% of the problem, our 80% of the issues will be resolved, isn't it?
Yeah.
So this is basically Pareto diagram. In fact, it is even more than that. Here we also look on the aggregate of the issues. Okay, and then we see that, okay, how much percentage, for example, if this is a percentage, how much percentage is contributed by one type of issue. For example, 46% are because our doors are too wide, so on and so forth. Scatter diagram. Scatter diagram is nothing but it just shows the trend. It shows that, okay, what's happening. This is one relationship between two variables. You can say X and Y. As X is increasing, Y is increasing. Another scatter diagram I'm drawing here. This is showing that as X is increasing, Y is decreasing. So inversely proportional, but there is still a relationship or a scatter diagram that is very random, and we cannot determine what happens when X is increasing. Y could be increased, could be decreased, remain same, so on and so forth. So to find this type of relationship between two variables is called scattered diagram. Document analysis, this is nothing but our research that we do from our organizational process assets, their repositories, their databases, or overall research. Alternative analysis, we have already studied about it. And this is also called what if analysis. What if analysis means that if you change uh, one condition, one variable, one resource, then what will happen? Process analysis. Process analysis we looked previously. We have we draw our processes from start to end, and we investigate how many steps this process takes, how many components are there, how many different roles and responsibilities are there, how many interfaces are there, how many decision making blocks are there. Now, how many handoffs are there within a process? How many different people are involved? What are their quality requirements and what are the quality issues? All those things are basically comes under process analysis. In fact, there is one specific type of process analysis. We call it value stream analysis. Value stream analysis says that, just give me a second. I'm just erasing everything. Value stream analysis says that, okay, if this is our process, in this process, what we do is we analyze it so that we can find out its efficiency. So after drawing the process, we try to find out the productive time and the waste time in the whole process. So think of these blocks are productive time and these blocks are waste time. By doing that, we can determine efficiency of this process. I am uh, defining efficiency with the help of ETA. Normally, this is standard for efficiency. Okay, so if you just think about 10 minutes here, 10 minutes here, 20 minutes here, uh, 5 minutes here, 10 minutes here, uh, 10 minutes here, and 20 minutes here. Can you determine efficiency for this process? Can you, anybody calculate it? Very simple formula. Productive time is 10 plus 10 plus 5, isn't it? So can I write it 25? And how much is total time? 10 plus 10 plus 20 plus 5 plus 10 plus 10 plus 20. How much it would be?
75.
Yeah, 75. And how? What is the efficiency of this process? 1 by
Third.
1 by third. That is 33%. So by doing that, what can we do? We can do some type of process improvement so that we can increase the efficiency of our processes. Normally, business analysts, they do this type of work, but it is also important for project manager to understand this concept. Hmm, does it make some sense? Did you understand about value stream analysis?
Yep.
Now, here it is also important to understand for different type of stakeholders, the meaning of productivity is different, isn't it? Let me share you an example. There is a busy dad who loves to make pancakes with his son on Sunday morning. He spends around 2 hours in making the pancake. For him, the productivity, the quality time is 2 hours. But on the other side, for the son, the quality time is when pancakes are ready and he eats it in 5 minutes, isn't it?
Yeah.
So different people, different perspectives. This is one thing that we also take into consideration. Then there comes root cause analysis. Root cause analysis could be of different types. One of them is Ishikawa diagram, that is cause and effect diagram, but also there
Sorry,
are,
guys. Could you adjust your headset, please?
sorry,
Could you adjust your headset?
just it looks like my speaker is not
That is
working.
good now.
Okay, thank you. So root cause analysis is of different types. I have already explained it, but for the sake of brevity, I'm just going to talk about it again. Root cause analysis could be of different types. One is fishbone diagram. The other one is 5 whys, where we investigate a problem and try to reach to its root by asking why 5 times. In fact, we really need not to use the word why in our questions, but keep on asking questions. 5 questions, and it is proven that you will reach to the root cause of a problem. Similarly, previously we talked about interrelationship diagram, where we see that uh, with the help of blocks, with the help of arrows, we try to find out that what are the root causes of any problem and what components are more affected. Multi-criteria decision analysis. This is a technique of decision making where you make the decision based on a criteria. You set a criteria, for example, regarding to quality requirements, quality requirement 1, quality requirement 2, 3, and then after that, on the other side, you set a criteria. For example, easy to implement, for example, less costly, for example, expertise available, and then you talked about its weightage. How much importance is to easy to implementation, or the cost or the expertise? Maybe easy to implementation weightage is only 0.2, and the cost weightage is around, you can say, 0.5, and expertise weightage is around 0.3. Okay, then what you do for each requirement, you do the voting. For example, there are 5 people in the meeting who are deciding about it, and 2 voted for easy to implement, 2 voted for quality requirement 1, 2 voted for cost, 2 voted for uh, experience or expertise. So it will be 2 into 0.2. It will be 2 into 0.5, and the next one will be 1 into 0.3. Sorry for my ugly writing. And then for next quality requirement, we do the same and we calculate the figures here based on the voting. Once everything is calculated, the next step we do is we calculate total score for each quality requirement, and whatever quality requirement will have higher score will be chosen to be added on the project. Make sense?
Yeah.
Then there comes affinity diagram. Affinity diagram is nothing but used for data representation. With brainstorming, when you gather a lot of ideas, then you combine similar ideas together to make some themes. This is done with the help of affinity diagrams. Audits. Audits are they are very formal procedures. They are done by the quality departments. The purpose is again assure the quality, conform with the quality requirements from the organization, from the government, from the regulatory authority, and ensuring that all the work is done as per the standard. As it's a formal process, quality reports are normally generated as a result of audits. Then there comes design for X. Anyone know about design for X?
No.
Eamon.
It's
Yeah.
like designed for excellence.
Yeah.
For example, to improve the efficiency for the designing and to like try to reduce the cost, improve, like anything you can improve the design to reach
Yeah.
the excellence.
True. So design for X is basically design for the excellence. And this X could be anything. Okay. You can look on your design while keeping efficiency in mind, and then you improve your design to improve its efficiency. Next time you look on your design, you design in such a way so that it should be designed for the cost with for the reduced cost. Similarly, you can do it design for the packaging. Uh, for example, you design your product in such a way that that could be fit in a particular form of packaging, so on, so forth. This is also used, but mostly in the manufacturing industry, in the mechanical or engineering industry. And then there comes problem solving. This technique is to look into the problem, look into the root causes, and uh, try to resolve not only problem but its root causes, and it also include the monitoring that okay, we resolve this problem, it should be resolved for good on our project, it shouldn't come back again. Outputs of this process are test and evaluation documents, quality assurance reports, quality audit reports, maybe some change requests. Those requests could be related to, okay, improve our process, so on and so forth. And project management plan updates or project document updates. So 4 outputs of this process. Control quality. This is our last process. Uh, this talk about verifying that the deliverables that are already produced are of quality. Either it is a product, service, or process improvement. Quality control must be done before customer acceptance exercise. As I already talked about the tools and techniques used on quality assurance or quality management, the similar tools are used on the quality control. But important thing is the focus. The focus of using the tools while we are managing or assuring the quality is to build the quality in our work. Whereas when we are using these tools like check sheet or tally sheet or any other tool, in quality control, the purpose is inspection. Now the final deliverables are in front of us. Now we have to look at it so that we can verify that this is a quality outcome, a quality deliverable. Before going in depth of control quality and its tools, let's talk about few concepts. They are linked with the statistics as well, but are used on the quality. The first term is mutually exclusive. What do you think, guys? What does it mean? Mutually exclusive. In fact, my question would be how you will distinguish or compare the two terms. One is mutually exclusive or exclusivity versus statistical independence. Uh, what do you think? If there are two variables, one is X, other is Y, how we will say that they are mutually exclusive or statistical independent?
So mutually exclusive just means that if you were doing the trial, you couldn't change both variables at the same time.
Yeah. So you really cannot change two variables at the same time. In fact, two variable doesn't exist at the same time. You can think of day and night. They are mutually exclusive. If there will be a day, there will be no night. Similarly, if you talk about to coin, its sides, either it would be head or tail. So they are mutually exclusive. On the other side, statistically independent. What do you think?
So maybe changing one variable has no effect on the other.
True. And in fact, the existence of one variable has no impact on the other. But it doesn't mean that they don't exist at the same time. They can exist, but uh, they are not dependent on each other. Then there comes probability. Everybody knows about probability or likelihood or chance, that is the chances of anything to occur. Then there comes normal distribution. Everybody know about normal distribution, but for the sake of understanding, this is nothing but a bell curve. Okay, it is a standard normal distribution. Most just take the example, one example. Normally, when a result of a class, for example, engineering class or bachelor or business students class, their results are produced. Normally, they check it for the normal distribution or bell curve. Most of the time, majority of the students are between C grade to, you can say, B plus grade, but you will find 2 to 3 students who are D grade or failures, and there are 2 to 3 students who got A or A plus. So this is our normal distribution. It is used to measure the variances. Statistical independence, we already talked about it. Standard deviation. What do you think, guys? What is standard deviation?
It's just the allowed deviation.
Yeah, or in other words, you can just say the deviation from the mean, isn't it?
Yeah.
So this is basically, oh, sorry. This is basically standard deviation. Okay. Now we will soon see what is allowed, what is not allowed, what requires investigation, what is random. But before going in depth of that, normally we denote standard deviation with the sigma. And in fact, there is a whole technique of quality assurance called Six Sigma. Very famous. It has its own certifications, starting from Six Sigma yellow belt up to Six Sigma black belt. Those are the guys who are expert in quality assurance and quality control on the processes. Tools and techniques, we already talked about most of them: checklists, check sheets, statistical sampling. And when we talked about statistical sampling, though we are going to discuss soon, but it is more about we do sampling in which situation? Can you tell? Instead of checking all the samples, we do statistical sampling.
Yeah, when you've got high volumes of product.
Yeah, high volumes of product, or for example,
An example of high volume.
yeah. So one example, high volume is one example of when we do statistical sampling. What would be the other situation in which we can go for statistical sampling, or we prefer, yes,
Or the opposite of it,
like
low volume, mean or median.
yeah. Yeah, but if it is low volume, we can basically do the sampling. We need not to do the sampling. We can check all the items because they are low volume. If we are checking for quality assurance and our items that need to be checked for quality assurance are, for example, 10,000, we cannot check all of 10,000, isn't it? So in that case, we do statistical sampling. We choose random, maybe only 200 out of 10,000. And if they are okay, mean we are okay. If 1% is wrong out of 200, we can say 1% would be wrong out of 10,000. So this is statistical sampling. Other reason could be when it is expensive. Yeah, when testing each item is expensive. For example, vehicle stress test, when they are vehicle safety tests, when they collide one vehicle at the time of testing with something to check its safety, it is expensive. Not only expensive, it is explosive as well. So in that case, we also do the statistical sampling. We really cannot test all the trucks and basically uh, bump them into a concrete wall. Uh, so in that case, we also do the statistical sampling. And when we talk about statistical sampling, there could be of two types. One type is called random sampling. And other type is called attribute sampling. Any educated guess? What is the difference between attribute sampling and random sampling?
Well, random, for instance, just picking picking a random age to gather information, for instance, or random groups,
Yeah,
random gender,
yeah,
gathering a particular information, and then attribute is getting a specific target or identifying the specific targets of, say, groups of people
true.
or groups of equipment to
I
get
agree.
information.
True. You can say that, for example, you chose people randomly from different ages. Out of 100,000 people, you chose 1,000 people and conducted their, for example, blood test. The whole thorough blood test, including iodine, iron, and red blood cells count, and so on and so forth. The thorough blood cells, that is random testing. On the other case, attribute testing is where you choose just one attribute. For example, we are going to conduct iron test, and you are going to conduct the iron test for the whole lot. Yeah. Did you understand what's the difference between two? Anyone?
Like samples are selected differently. One is probably more singular on a particular attribute, or focus point and random can be multiple.
Yeah. And also if you take the example of, for example, doors again for a multi-story 5-star hotel, where there are, for example, 10,000 doors, random sampling is out of 10,000, you check 500 doors for their width, for their height, for their length. Okay. The other way is instead of checking width, height, or length, you only check the width, but for all 10,000. The first one was random sampling. You chose sample randomly. In the second case, you just chose one attribute and checked the whole lot. So that's the difference between random and attribute sampling. Questionnaires and surveys, we already talked about them, normally conducted for a bigger size population to gather quick results. But the design of the surveys, the conduction of the surveys, and the management of the surveys is a big task. And also the quality of feedback is always a challenge while conducting surveys. Performance reviews, that is again just like an inspection where the stakeholders, the clients, they come and they review the performance of the team. Root cause analysis, we already talked about it. Inspection, this is done when our deliverables are produced, and that inspection could be done with the help of other quality control tools or with the help of some testings, especially in the software industry. Unit testing, integration testing, system testing, exploratory testing, usability testing, all these are different type of testing that is used. In construction, stress testing, so on and so forth, all these are different type of tests that could be conducted as a part of inspection. And then there comes control charts. We are going to discuss control charts soon, but the purpose is to assure the quality. Check sheets, that are a derivation of checklists. We also call them tally sheets. They not only do tick box exercise, but also they keep the track of the data. Mean how many doors were long? How many? 7. How many were narrow? 3. How many were wide? And how many were short? So this is just one example of tally sheet or check sheet. Statistical sampling, we already talked about it. We normally, instead of doing the test of the entire population, we choose the samples, but it should be a valid sample. It could be done when the whole population testing takes too long or too expensive or could be too destructive. Then there comes control charts. Let's explain the control charts with the help of our whiteboard. What I'm going to do, I'm going to draw a control chart. It's better to draw it again so that it should make more sense. Okay. Now I draw y-axis only for the sake of better understanding. On this y-axis, I'm trying to draw a control chart. First of all, I am drawing a mean. How many of you don't understand what does it mean or average?
All good.
All good. So mean or average is just the average of all the values. Normally, when we have mean, after that we start taking samples. Okay. Mean our work is started. we are assuring quality or we are controlling quality on our deliverables. Just think of a pen, just a writing pen. Okay. Our client requirement is the diameter of the pen should be, you can say that, okay, 20 centimeters. This is a requirement from our client. So the focus is, let me write it here, 20 centimeter. That's the average our client is accepting. But he says plus minus, I really can't write minus here, but think of plus minus 5 centimeter is fine. Mean the specification from the client is, if anything that is between just excuse me, I'm trying to draw a line here. Okay, so this dashed lines, this is our client requirement. Anything between 15 centimeter to 25 centimeter as a diameter is acceptable. When we have this type of specification, what we do is we put a control limit. You can clearly see that this specification could be called upper specification limit and lower specification limit. You can call them USL and LSL. Similarly, as a project team, as a supplier or as a vendor, we set our control limit that is normally more controlled than specification. And we say that we will create our product that will be in our control limits, that is, instead of plus minus 5 centimeter, we are putting them plus minus 3 centimeter. Okay, because we really want to fulfill our client requirements, but we set our own standard. So as long as the pen is between 18 centimeter and it would be how much? No, not 18. I'm sorry. 23 centimeters. Yeah, 23 centimeter and yeah, I need to erase something here. Sorry guys. So 23 centimeters and at the bottom 18 centimeter. Sorry, 17 centimeters. We are fine. We will say our process is good, our manufacturing equipment is performing good, our team is performing good. In fact, here I am taking the example of one manufacturing, but it could be applied to anything, any deliverable, any process, anything, totally depends. Okay, so now we set this control chart. We got our upper specification limit, lower specification limit, upper control limit, lower control limit. Now our process starts. We start getting value. Values will be like this. Few values would be 21, other would be 19, 22, 21.9. Few will be even on the line itself on 20 centimeter. No problem at all. We are within our control limits. We are doing good. Our quality is good on the project until anything goes beyond our control limits, either upper control limit or lower control limit. If there is any variation within the limit, no problem. This is called general cause variation. These are random variations. We really don't worry about it. However, if there is a variation that is beyond our control limits, then basically it triggers the alarm. It says that, okay, this variation is not general cause variation, but this is a special cause variation that is assignable. Mean we need to do some investigation why it happened that our one of the pen that was created was with diameter 23.5 or with diameter 16.5. So this is the control chart. However, when we are talking about general cause variation and special cause variation, another important thing you need to remember is, in case if our values are coming 7 values, this is called rule of 7 on, so 7, isn't it? On one side of our mean, as you can see here. Can you see here? Our one side of the mean. Okay, this is called rule of 7. It says if there is a rule of 7, if it is still under our control limits, upper or lower, still it is a assignable cause. Reason, it is not a random variation. There is something there. Okay. So we need to investigate why we are getting the values on one side of our mean. Is there any issue? Is there any precision issue? Or is there any accuracy issue? What's the problem? So that's how we use our control chart. In fact, many departments, even government departments, they use this rule of 7. For example, if someone is on work and income or on a dole, nobody will investigate him. But if he remained there for a long time, like for example, for 7 years or something like that, then they start investigating what's the problem, why this person is doing the same. Or if you are showing loss to your business for a long time, for 1 to 3 years, it's fine. But if it cross that threshold and you are still showing the loss, then they ask why you are doing this business. What's the problem? So this is also a spatial cause variation. Any questions? Now let's go back to our slides and keep on discussing our rest of the topics. We talked about control chart, we talked about upper and lower control limits, we talked about mean, we talked about specification limits. Specification limits comes from customer, upper and control limits are set by the team. We really want our variation should be within our limits. Though we really want to reduce those variations. We really don't want that our variation, though within control limit, are still big. We want them near to our mean. Not only precise, but also accurate. I just talked about Six Sigma. Six Sigma talks about reduced variations, not a lot of variations with bigger value of standard deviation. In control charts, we talked about out of control. We talked about the samples that go outside upper or lower control limits, or the samples that are non-random, like rule of 7. It is also given here, but we already talked about it. We talked about general cause variations or special cause variations. Special cause variations are with assignable causes. This is one sample of control chart, but we already discussed about it. So I'm moving further. Then there comes cause and effect diagram. As Tanya said, that is, it is called Ishikawa or fishbone, or sometimes we call them bye-bye diagram. To me, I think this is wrong bye-bye. This is, no. They are trying to write 5 bys. No, not 5 bys. Nevertheless, if it is Ishikawa diagram, we call it WYE instead of WHY. Okay, WYE, bye-bye diagram. Now, what is the purpose of it? The purpose of it is we investigate one problem and its causes. And we put the problem at the head of a fish, whereas we put the causes, the main categories, on the bones of the fish. I'm going to explain this with the help of my next slide, because the fish on the next slide is better than this. So this is the fish. The problem is, in fact, I run this when I run my ACP classes, Agile
A
Certified.
very nice example.
Yeah, yeah. In fact, I run this class, this example when I conduct my ACP, that is Agile Certified Practitioner course, and where we sit down and we see that if we failed in PMI ACP exam, you can think of, though I'm pretty sure all of you will get above targets in all of the domains in your first attempt, but in case, unluckily, if someone fails, how can he or she use fishbone diagram to find the causes for that? Okay, so who can help me to go through the major categories? Grace.
Preparation. Lack of real world experience, did not follow study plan, did not allow enough time.
Yeah, so in prep, that's a major category, and then there are some subcategories, not a real experience, or didn't follow the study plan, or really couldn't get time to prepare for it. Second major category, Tanya.
Which one do you want? Exam.
Yeah.
So I spent too long on some questions, kept dwelling on questions I'd already answered, did not read through all answer options.
In fact, that is a common practice. Sometimes people start spending like more than 2 minutes on one question. If it is increasing more than 2 to 3 minutes, leave that question for later check, or kept dwelling on the question I would already answered. Sorry, I had already answered. So don't go back and check, did I answer correctly or not? Or if there are 4 options, what people do, they just look on first option very carefully. They don't look on second and third or fourth option that carefully as they looked on the first option. So what they do is they just click the first option, because to them first option looks much more accurate. They even don't bother to go to the rest of the options. So this could be the one reason of failing exam. Pedro.
The material, use free online questions that were not aligned with the exam, and reviewed contradicting web resources.
So in fact, PMP, it is there for like since 1986. It's almost more than 34 years. So internet is full of PMP questions. So it's very important to know that which questions are correct, which questions are up to the mark, very near to the actual exam. So even you will find out some question that would be contradictory, or even will make you confused, will basically, instead of correcting your concepts, will make them even more confused. So it is very important to understand which question banks need to be used. That's why I'm providing you 600 question banks. I think you already got it. And also the free links given in chapter 1. Next, Eamon.
Methods, insufficient agile training.
You can think of project management training in this case. Okay.
Not enough practice exams, poor study plan.
Yeah, either study plan itself is poor, or you don't have right and enough practice exams, and your course that you did, the teacher was not that good, who provided you a good training, or you missed few sessions, so on and so forth. That could be the reason. Okay, next, environment, Sukanya.
Too busy at work to study, personal issues, and lack of family support.
So no, this is the case, in fact, for with most of us. Now, what happens in fishbone diagram? We do this thorough investigation. After that, as a team, we try to identify what could be the reason. What is the major reason? Okay, insufficient agile training or project management training. It's okay. This could be the reason, but this is not the main reason. What could be the main reason? Now, as a team, we decide what is the main reason. But here, the situation is not like a team situation, but it is more like an individual situation. Everybody's circumstances are different. I am going to give you 30 seconds and you are going to tell me that which one applies you the most in case unluckily you fail your PMP exam. 30 seconds, please. Okay. 30 seconds are passed. What do you think, Tanya? What could be the reason if you unluckily fail the PMP exam? What could be the main reason?
Sure. My most likely one would be did not allow enough time, which
Yes.
goes hand in hand with the too busy to study.
Environment?
Environment and prep.
Yeah, environment and prep. And in prep, which one?
Did not allow enough time.
Yeah. So that's one of the reason. Thanks, Tanya. Next.
Yeah, in my case, it's also a combination of that preparation and environment, but in preparation, it's same as Tanya. That's not allowing enough time.
Yeah.
Environment will be
Mm-hmm.
those first two right there, too busy at work to study. And then personal issues, maybe not so much of an issue, but just the engagement, personal engagements,
True.
again, relating to time
Yeah.
constraints.
Yeah, especially if you have like little kids. It happened with me. You know, it's a nightmare. During my like lockdown, I really couldn't do anything because of my small little kids. 1.5-year-old is always like around my legs. He really want me to pick him up all the times and keep on playing with him. So yeah, it happens. Pedro.
Um, For me, it's also the same, the preparation, and also for the environment. For preparation, it's more of not allocating enough time to do the studies. And at the environment is more of sometimes you get entangled on a lot of family activities.
Yeah, true. So some personal or family related things. What else? Oh, sorry. Our next participant, Eman, what do you think?
Yeah, for me too, is the time is not enough to study well, and I think for as another method which is not enough practice exam. I think still until now we did not practice much about the exam. So I think we need to practice more for that as well.
True. So this could be the reason, another reason. It may include you don't have enough practice exam or didn't get enough time to practice exams. Sukanya.
Yes, in my case, also in preparation, like not lack of real world experience.
Yeah.
And also environment, like I'm also too busy to work.
Yeah.
And I think in method also a poor study plan. So I have to improve my study plan.
Yeah. So like this. In fact, in this case, because circumstances and backgrounds are different for all the aspirants, you can think of like it could be individual, but in real world, normally teams, when they make a decision based on consensus or voting, you can see that here, this option, as Pedro, Grace, Eamon, and Tanya said that they don't have enough time, and also Sukanya, as she said. So this could be the main reason. In fact, this is talking about didn't allow enough time. We might have enough time, but we didn't give that much time to our prep. So this was just one exercise about fishbone diagram that could be applied to anything. Any questions? Histograms, we already talked about histograms. They really don't, they provide us information, but not in a sequence, not that needs immediate attention. Okay. But on the other side, Pareto charts, they help us to identify those major reasons that cause most of the problems or most of the errors or most of the defects. Scatter diagram, we already talked about scatter diagram. So I'm skipping this too. And then that's the end. Output of this process control quality is our measurements, our changes, validated changes, WPI, work performance information, project management and project management plan and documents update, change requests. That is basically talking about corrective actions or preventive actions or defect repair. And at the end, verified deliverables. That's what we really need so that we can present to our stakeholders. Guys, think about this output too, validated changes. It is talking about once there are some change requests, suppose these are three processes, planning, assurance or quality management and control. Okay, so these are step-by-step processes. In quality control, when we checking the quality, we may have some change requests that could be corrective actions, preventive actions, or defect repair. Now, where these change requests will go? Into the work where we are doing our assure quality. So, we are going to rework something or we are taking preventive or corrective measures to ensure that everything should be all right. It means that we made some changes. Now, these changes that we made, they also go to control quality, and these are validated that, okay, these changes were implemented or not. Did I make some sense here?
Yep.
So it is a confirmation that changes are implemented properly or not. Now that's end of our chapter, but just a quick review. Please help me, Grace, by going through the key concepts that we covered today.
Key concepts. Quality is required for all type of projects and deliverables. Quality measures are different for different projects. Failure to meet the quality requirements because of meeting stakeholders' requirements or schedule.
So sometimes it happens that we cannot meet our quality requirements. That could be because of stakeholders or could be because of our scheduling constraints.
Quality versus grade.
We know the difference, isn't it?
Yep. Prevention versus inspection.
Though inspection has its importance, but we prefer prevention over inspection.
Attribute versus random sampling.
We already had a look the difference between two.
Yep. Types of cost of quality.
Again, quality conformance and non-conformance. Yes, and then there comes trends and emerging practices. Pedro, can you please help me to go through them?
Yes, Faith. Modern quality management includes minimized variation,
Yeah.
Customer satisfaction, continual improvement, management roles, mutually beneficial partnership with suppliers, and modern techniques such as TQM, Six Sigma, Lean Six Sigma.
Minimized variation is talking about Six Sigma. This is the focus of Six Sigma technique. Customer satisfaction is one of the most important quality measure. Continual improvement is like improvement in the work, improvement in the deliverable, in the project, in project management work, in products, even in the professional and personal development, or even the personal life of a employee. All those things are considered in continual improvement or Kaizen. Management roles, especially in terms of governance, where they involve to confirm that work is being done and they accept the deliverables. Also, when decisions are made about the quality, they can understand the importance of quality and they can provide the funds, the budget for the quality assurance and control. Mutually beneficial partnership with suppliers, very important. Nowadays, it is a new trend, not a new trend, very important trend in supply chain management. Suppliers are the best source who can provide you that feedback, that guidance, that support that help you to have a very good quality outcomes. Maybe you heard about SIPCO. Sorry, SIPOC. Anybody know about it?
Yeah.
Yeah. So Tanya, what is this?
It's just defining a process from start to finish, using suppliers' input, processes, outputs, and customers.
Yep. So from suppliers till consumers or customers, and this is that method where we assure that quality is there from start till end in our processes. Some other modern techniques, total quality management, Six Sigma and Lean Six Sigma, that not only talk about minimized variation, but also talk about minimizing waste. Lean is all about minimizing waste. Tailoring considerations while you are developing your plan, doing quality assurance and control activities, you can take these into considerations. policy compliance and auditing requirements, standard and regulatory compliance, continuous improvement, and stakeholder engagement. Consideration for agile and adaptive environment. Tanya, can you please read this for me?
Frequent quality and reduced steps built in throughout the project.
Yeah, so in agile, it is claimed that, and that's the fact that because of frequent reviews, frequent feedbacks, and shorter feedback loops, quality is much more built in agile way of working. It starts from seconds, it goes up to months. So quality is being assured in seconds, in minutes, over the days, and over the weeks and over the months. When we say in seconds, I'm talking about pair programming. When I talk about minutes, I'm talking about testing, unit testing. When I'm talking about days, I'm talking about daily scrum meetings. Weeks, that are our retrospectives meetings, and months, and also our iteration and their reviews. And months, basically talking about our releases. We always have recurring retrospectives for process improvement, product and people improvement. And also we focus on small batch system. In other words, we complete limited amount of work, or we focus only limited amount of work that could fit in 2 weeks time. Or even if it is not time boxed, it is, for example, flow based agile, such as Kanban. Out of product log, we only take one item at a time, or maybe two maximum. We work on that until it is not completed. We really don't pick the other item. So small batch system. All these are agile ways of working, agile mindset that help us to assure the quality on the project. And that was end of today's sessions. Now, if you have any question answers, just feel free.
No, good session, thanks.
Okay, thank you everyone.